All right, everybody, let's go over the first sample test for our first test on Monday. The first question says, show the subsets in the set given below. So the set is the set 2, 3, and 5. So what we need to do is find the subsets in that set. So it could be any combination of the numbers in it. It could be all of the numbers, or it could be none of the numbers. So I went ahead and showed you have all of the numbers. You've got 2, 3, 2, 5, 3, 5. You have just 2, just 3, just 5, or you have an empty set or a null set. Sorry. You can double check and make sure you have all the sets you need. You take 2, which 2 comes from either being able to have a number in the set or it is omitted from the set. So you take the 2 and you multiply it, and you find how many elements are in that set, and you put the 2 to the power of that. So there's 3 elements in the set. So you do 2 to the third power, and so that would be 8. So 2 times 2 is 4, times 2 is 8. So you could count 1, 2, 3, 4, 5, 6, 7, and 8. And I believe she really does want you to write them all out for the test so she can see that you've done it, not just do the equation. But if you do the equation, you can check and see if your work is correct. All right, so number 2 is going back to sequences. So first what we need to do, it says indicate the type of sequence represented by the numbers below and find the nth term in each of the sequences. All right, so number 2, first we start with 4, 8, 12, 16, and 20. So what we need to do is find what the difference between each element in that group is. So we've got 4 to 8 is 4, 8 to 12 is 4, 12 to 16 is 4, and 16 to 20 is 4. So each time we're adding 4. So that means A is going to be an arithmetic sequence. So we need to find the nth term. So here for our first term equals 4. So it's going to be 4 is equal to 4 plus 0. And this is a plus because it's the arithmetic we're adding to get to the next term. So then we have n minus 2, or when n is 2, the second term is equal to 8. So 8 is going to be equal to 4 plus our difference, which would be 4. So our difference is this 4. So when n is 3, our third term is going to be equal to 12. 12 is equal to 4 plus 4, that our difference, and 4 our difference. Then n equals 4, our fourth term can be equal to 16. 16 equals 4 plus 4 plus 4 plus 4. Okay, so now we have our, we can see what our pattern is. We're adding 4 to each of the next terms. So now we need to find, if we wanted to find, let's say, the 10th term or the 5th term, we would be able to use the formula. So you would do the nth term. It's going to be equal to our starting number, which is 4. So this is our starting number, plus our, all right, so we've got our starting number 4. So we're adding that to our difference, which is going to be 4. So we have the 4s, those are our differences. And then that's going to be equal to n minus 1. So if we wanted to check for that 5th term, we would say 4, our starting number, plus 4, our difference, times 5 minus 1. So that would give us 5 minus 1 is 4, times 4. So I have 4 times 4, 16, plus 4 equals 20. So that means our fifth term would even 20. One times 3 is 3. 3 times 9 is 3. 9 times 3 is 27. And 27 times 3 is 81. All right, so we need to find the nth term. So first we start with saying when n is equal to 1, the first term is equal to 3. Oh, first term is 1, sorry. So then we have 1 equals 1 times 1. So this is a multiplication because we're multiplying here. So then our next term, so this will be called a geometric sequence because we're multiplying. So if when n is 2, our second term is equal to 3. So 3 is going to be equal to our starting number times our difference. So then we have n equals 3. Third term is equal to 9. So 9 is going to be equal to our starting number times our difference times our difference. And then when n equals 4, fourth term is going to be equal to 27. So 27 equals our starting number times our difference times our difference times our difference. All right, so now we need to find the nth term. So the nth term could be any number in the sequence would be equal to our starting number 1 times our difference 3, and then we're going to be going n minus 1 to the power. So if we want to test this method, we will say like, let's try to find the fifth term. So our fifth term, we would do 1 times 3, and then be 5 minus 1 to the power. So 1 times 3 to the 4th power. 1 times 3. Oh, yeah. Sorry. 3 to the 4th power is 81. So 81 times 1 equals 81. So that would be our fifth term. All right, let's go to C. For C, we have another arithmetic. So for 10 to 13, we have adding 3. 13 to 16, we add 3. 16 and 19, we add 3. So this is arithmetic sequence. All right, so first we do our first term. N equals 1 equals 10. So we have 10 is equal to 10, our starting number, plus 0. We're doing a plus because it's arithmetic. So we have n equals 2, our second term. Second term equals 13. So we have 13 equals 10 plus our difference of 3. Third term is equal to 16. So 16 is equal to 10 plus 3 plus 3. Our fourth term is equal to 16. 16, oh, not 16, 19. 19 is equal to 10 plus 3 plus 3 plus 3. All right, so our nth term is going to be our starting number 10 plus the difference, which is the 3. And then we're going to be multiplying that by n minus 1. All right, so let's just test this. So if we have 19 plus 3 be 22. So let's see if our formula works out. So if we do our fifth term, it's going to be equal to 10, our starting number, plus 3, our difference, times 5, which is the number in this, the term that we're looking for in the sequence, minus 1. So that would give us 10 plus 5 minus 1 is 4. So 4 be 3 times 4 is going to be equal to 10 plus 12, which is going to be equal to 22. 22 is what we got. So we know our formula is correct. All right, let's try D. D, we have 11. Okay, so we're doing plus 11, plus 11, plus 11. So we need to start with our first term. When n equals 1, our first term equals 7. So then we have 7 equals 7 plus 0. We're using the plus because it's arithmetic. Sequence. So then when n is 2, our second term is equal to 18. So 18 is equal to our starting number plus our difference. Now n is 3, our third term equals 29. So 29 is the same as 7 plus 11 plus 11. When n equals 4, our fourth term equals 40. So we have 40 is equal to 7 plus 11 plus 11 plus 11. So if we wanted to find the fifth term, so let's see, we're just adding it, it would be 51. Let's see if we can get it to work out. So nth term would be equal to our starting number, which is 7, plus our difference, which is the 11. And then we're going to be going n, oh, that's wrong, n minus 1, like multiplied. So let's try like the fifth term. This is going to be 7, our starting number, plus 11, our difference, times we have the 5 minus 1. So that's going to be equal to 7 plus 11 times 4. 11 times 4 is 44, plus 7, which is going to be equal to 51. So that means our fifth term is going to be equal to 51, just like we said. And let's go down to E. All right, so this one we actually have a geometric sequence again. So you have 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So this is a geometric sequence. So you have n equals 1, our first term is going to be equal to 3. So we have 3 is equal to 3 times 1. So we're multiplying because it's a geometric sequence. So we have n equals 2. Our second term is equal to 6. 6 is going to be equal to our starting number times our difference. For our third term, we have 12. 12 is going to be equal to 3 times our starting number times 2 our difference times 2 our difference. Our fourth term is going to be equal to 24. 24 is going to be equal to our starting number times our difference times our difference times our difference. All right, so let's see if we can find the nth term. Would be our starting number 3 plus our difference 2n minus 1. Let's see if we got this. Oops. We have, okay, so if we want to find the next term, our fifth term, so it'd be 24 times 2 would be 48. Let's see if we could make sure that works. So we have our fifth term, be 3 plus 2 to the 5 minus 1. So that would be 2 to the 4. And we got 2 to the 4 equals 16. Wait, these are supposed to be multiplied. So 16 times 3 is 48. All right, so this is our nth term. That's a geometric sequence. Okay, just checking I did it all right. Okay, so now we're on F. We have 2 to 6. I think we're multiplying by 3 here. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. All right, so this means if we're multiplying, it's a geometric sequence. All right, so you do n equals 1. Our first term equals 2. 2 is equal to 2 times 1. And we're doing multiplication because it's a geometric sequence. And n equals 2. Our second term is equal to 6. So 6 is equal to our starting number 2 times our difference times 3. We have n equals 3. Third term equals 18. So if 18 is equal to 2, our starting number, times 3 times 3. N equals 4. Our fourth term is equal to 54. 54 is equal to 2, our starting number, times the difference, times the difference, times the difference. All right, so let's say if we did this times 3, that would give us 162. So let's just check and see if that works. Our nth term would be equal to our starting number, which is 2, times our difference. We're multiplying here because we're geometric, times 3 to the n minus 1 power. So that would say we're doing like the fifth term, just to check our work, we would have 2 times 3 to the 5 minus 1 to the 4 equal 2 times 3 to the 4. Oops. So 3 to the 4th power is 81 times the 2 gives us 162. So our nth term checks out, and it's a geometric sequence. Okay. Number 3 says identify n for set S for the given set. So the set is 1, 2, 3, 4, 5. So n is equal to the number of elements in each set. So we have 1, 2, 3, 4, 5. So n equals 5. So the n stands for the number of elements in a set. All right, so now we're going to be using area multiplication model to solve the following. So we have 3 1/5 times 2 1/3. So of course we're going to do is make a rectangle. And we're going to divide the first side into 4 because we know it's going to be more than 3 but less than 5. All right, so we know the last column, it's going to be only 1/5 of that column. So we need to divide this last column into 5. 1, 2, 3, 4, and 5. Close enough. And then we've got, so we have 1, 2, 3, and this is the 5th. So in the other direction, we want to divide it into 3 because we know it's more than 2 but less than 3. So we're going to divide it into thirds this way. So then we have our 1, 2, and we need to divide this side into thirds. We have 1, 2, and 3. All right, so you know this is a third, and each of these are 1/5. All right, so this side's going to be a 3 1/4. So all this gets highlighted, 3 1/5. So that space represents the 3 1/4, 3 1/5. I don't know why I keep saying 1/4, 3 1/5. So now we need to show the 2 1/3. So we have 1, 2, third this way. All right, so now what we have to do is we need to find everything that is included in that area. Okay, so we have 1. These are all equal to 1 unit. This is equal to 1/5 of a unit. These are to a third. These are a third. All right, so the only one we are kind of in question about is this last cube right here. So technically, the whole unit is down. Whoops, that's too big. Is down here. That is in question of this one little part of that whole unit. So we need to figure out what the value of just that one little cube is. So we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that would mean this is 1/15. So now what we do is we add up all of the shaded area in the values of each. So we would have 1, 2, 3, 1, 2, 3, 4, 5, 6. We know we have 6 holes plus 2/5, so 1/5 and 2/5, 2/5 plus 1/3, 2/3, 3/3. So that's 3/3 is the same as 1 plus 1/15. I'll show that a little bit different. 1/15. All right, so this means we have 7 plus 2/5 plus 1/15. And what we need to do now is find the lowest common denominator to find, be able to add them together is 15. So that would give us 7 plus, say 5 is 3, 3 times, so it'd be 6/15 plus 1/15. So that would give us 7 and 7/15. So let's let's see if we can check and make sure we got this correct. So you would take 3 times 5 is 15 plus 1 is 16/5 plus, oh no, be times, and 6 be 7/3 if we cross multiply. So then we multiply across, so we've got 15 in the denominator, and 16 times 7 is 112. So 112 divided by 15 is 7. Okay, so that would be 7. It'd be 7 times 15 is 105. So 112 minus 105 is 7. So it'd be 7/15. So our 7/15 is our answer using the multiplication model, the area multiplication model. All right, let's try next one. We're gonna make a rectangle. Didn't work. That's a square. Okay, so let's take and divide. We know this one is more than 4, but less than 5. So we need to split this in 5s. And the last column is going to be split in 2 because we're only using half of that unit. So this is 1, 2, 3, 4, 1/2, oops, 1/2, 1/2. So now the rows, we need to divide it into 4 because we know it's more than 3 but less than 5. So we're going to split it into 4. So we've got 1, 2, 3. So, excuse me, this is going to be divided into thirds. And we've got 1/3 here, 1/3, 1/3, 1/3. These are halves. These are all full units. So let's do the 4.5. Let's see what that will show us. So we're going to go this way. And the 3.25, we're going to show vertically. So you have 1, 2, 3. I keep saying 1/4, 3 1/3. Sorry. Got all that shaded, and now I need to find the combination of what it all entails. Okay, so the only one that's kind of in question now is this last tiny piece of this unit. So if this unit is a full unit, this would only be 1/6. So we have 1, 2, 3, 4, 5, 6. So this piece is equal to 1/6 of a unit. So now we need to just add up all the pieces of the puzzle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 full pieces plus we have 1.5. So plus 1.5 plus 1, 2, 3. So that's 3/3 is 1. So we have 1/3 plus 1/6. So that would give us 12, 13, 14 plus 1/2 plus 1/3 plus 1/6. So then we need to find the least common denominator to add them together. And then that's going to be equal to 6. So we have 14 plus 3/6 plus 2/6 plus 1/6 is going to be equal to 14, see 3, 4, 5, 6 plus 1. So this would be 3, 4, 5, 6. So that's going to be equal to 6, 6, which is going to be 1. So our answer is 15. So we can check our work by saying, let's see, 2 times 4 is 6 plus 1 is 7. 7/2 times 3 times 3 is 9 plus 1 is 10/3. And you would multiply across, so you would have 70/6. That's not right. Sorry, I can't multiply. So 4 times 2 is 8 plus 1 is 9. So this would be 9/2. And then we have 3 times 3 is 9 plus 1 is 10. So 9 times 10 is 90. And then we have 2 times 3 is 6, which is equal to 15. So it does check out. All right, so number 5 says a frog is climbing out of a well that is 18 feet deep. The frog can climb 3 feet per hour, but then it rests for an hour, during which it slips back 1 foot. How long will it take for the frog to get out of the well? Show your method. Drawings are acceptable. What I did is I just created a number line um, for the 18 feet that are the depth of the well, and I started over here at 18 and got my way to 0, which would be out of the well. So I just modeled how for every hour the frog can jump the 3 feet. But then he rests for 1 hour, and as he rests, he goes back a foot. So that takes an hour. And then at the next hour, he can jump 3 feet and go back an hour. Then he jumps 3 and goes back 1, 3, go back 1, 3, go back 1, so forth. And I got up to the end over here, so he jumped from 4 to 1 and then back to 2. And then when he got for this 2, he only jumped 2 spaces, 2 feet, which I found like each foot, if it's like an hour, it would be 20 minutes. So 20, 40. So I say the last little bit that he jumped is only going to be 40 minutes, not a total hour. So that gives me, if you add it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 plus the 40 minutes. So I have 16 hours, 40 minutes. I could be wrong, but that's my method of doing it. So I guess as long as you draw what you started with and you can show how you got it, I think it will work. Okay, so if you have any questions, don't hesitate to call. It says, given that n set p is equal to 12, so that would mean like a set p is going to be equal to, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It says any q proper subset of p, and q is a proper subset of p. So that means okay, so if q is a proper subset of p, so that means q can only have max number of digits being 11. Now, it could be any of the 11, but it has to just have 11 because otherwise it wouldn't be a proper subset, because a proper subset has to have one less than the full set. It says there's a maximum. So the least number of elements that Q can have is 11. Is there a maximum limit on the number of elements that set Q can have? Yes, I can't have more than 11. All right. Use the lattice method to multiply. Explain why the method works. All right, so the lattice method, we make a square. And we're going to divide it by the number of digits in the number. So we're going to go 1, 2, 3, 1, 2, and 3. So we're going to put 4, 5, 8, 2, 4, 5. And then we're going to divide all of these out. Okay, so we start with the top. We have 2 times 8 is 16. 2 times 5 is 10. 2 times 4 is 8. So you put the zeros in 8. 4 times 8 is 32. 4 times 5 is 20. 4 times 4 is 16. 5 times 8 is 40. 5 times 5 is 25. 5 times 4 is 20. So now what we're going to do is we're going to add by sections. This is a section. Okay, so let's go back. So we're just adding straight across now. So the first row would be 0. Second one would be this row. 5 plus 4 is 9, plus 2 is 11. So you put the 1 here. You're going to carry that 1 up there. So 6 plus 1 is 7, 8, 9, 10, 11, 12. The 2 goes here. You're adding the 1. So you have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. Carry the 1. 2 plus 8 is 10, plus 1 is 11. Carry the 1, be 1. So our answer is going to start up here and go all the way down. So our answer is going to be 1, 1, 2, 2, 1, 0. So 112 to 10. Let's just double check our work. So we have 250 or 458 times 245. 112,210. So that's correct. So B, we've got to make a square. And we're going to divide it into thirds. This way and thirds this way. And let's see, 345, 567. Something like that. All right, so start multiplying. 5 times 5 is 25. 5 times 4 is 20. 5 times 3 is 15. 6 times 5 is 30. 6 times 4 is 24. 6 times 3 is 18. 7 times 5 is 35. 7 times 4 is 28. 7 times 3 is 21. All right, so we're going to add a straight across. We've got 5. We have 8 plus 3 is 11. Oh, we put the 1 and then carry the other 1. So 5 plus 1 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So put the 6 here, carry the 1. 2 plus 1 is 3, plus 2 is 5. 5 plus 8, 13 plus 2, 15. Carry the 1, 3, 8, 9, and then 1. So our answer is 1, 9, 5, 6, 1, 5. Let's just double check our work. 345 times 567, 195,615. Check. All right, number 8. State contrapositive of the following statement. If you are a gazelle, then you are a lion's dinner. So the contrapositive is the opposite of the converse. So that means it's the opposite. It's the negative meaning and the opposite position. So we would say if you are not a lion's dinner, then you are not a gazelle. So it's the opposite meaning in the opposite position. So the beginning switches to the end and it negates it. Number 9, a farmer has a son who needs more practice in mathematics. One morning, the farmer looks out in the barnyard and sees a number of pigs and goats. The farmer says to his son, I have one and a half times more pigs than goats. I count 80 feet. How many pigs and how many goats are out there? So in our group, we discussed the best way to figure it out is both sets of animals have 80 feet. So we need to divide 80 divided by 4 is going to be equal to 20 animals, right? 80 divided by 4 is 20. So we have 20 animals total. And then the farmer says, I have 1.5 times more pigs than goats. So if you divide 20 divided by 1.5, you get 13.333. So we know we can't have more than like half of an animal. So we know we have to have like 12. So we do 20 times 1.5. It's going to be like 13.33 repeating. So we can't have 13, like half of a pig or half of an animal. So that would mean we would have 12, doesn't matter, 12 pigs. So if we have 12 pigs, say 20 minus 12 is 18. So that means and 18 goats, right? Where did I get? No, that's not right. 20 minus 12 is 8, not 18. So 20 pigs and 8 goats, sorry. And that was the total amount of animals on the farm. So first you start off with saying, okay, there's 80 feet. Can't have 80 feet. Or we don't know how many animals 80 feet are. So we divide it by the number of legs each animal has. So both sets of animals each have 4. So you divide 80 divided by 4 gives you 20 animals total. Then you know you have 1.5 times more pigs than goats. So you would take the 20 divided by 1.5, gives you about a little over 13. Can't have an uneven amount of an animal. So you kind of round down. You would say 20 pigs plus 8 goats. All right, so we're at number 10. Given that union U equals whole numbers, shade the appropriate section represented as follows. So A union B and union C. So that means everywhere that all of them are joined. So that is what that represents. And then A union B minus C is going to be equal. So all of A and all of B we're taking out the part that is equal to, that's included in C. Number 3, it's a little bit trickier for me, I think. So what this is, it just means it's the complement of the union, the set. So you would have, it's pretty much the opposite of this one because it's the same sets, but we're using the complement, which is like everything that's not included in this. So it would be everything in here, if that makes any sense. Should. Let's see. All right. So now we're going to do converting from base 3 to base 10. To do that, we need to take and multiply the number times the value of the placeholder. So we need 3 to the 0, 3 to the 1, 3 to the 2. So 3 to the 0 power is 1. So 1 times 1 is 1. We're going to add 3 times 2 is 6, plus 9 times 1 is 9. So that's going to give us 9, 15, 16, base 10. So the answer is 16 base 10. It says convert 45 base 6 to 8. So in order to do that, we need to go from 6 to 10 and then from 10 to 8. So we need to multiply. So we have 5 plus 6 times 4 is 24. It's going to be 29. So we have 29 base 10. Now we need to divide the 29 by the 8 value places. So we would do 8 is 1, 8, 1 is 8, 8, 2, 64. Now 64 is going to be bigger than the 29, so we're not going to use that. So we would start with the 8. So you would take 8 divided by 29. 3 is 24. Times 3 is, oops, it's 5. All right, so we have 3, remainder 5. We're trying to find remainder 0. So we would take our leftovers and we would divide it by the next digit, be 1. So 1 divided by 5 is 5. Remainder 0. So our answer would be 35 base 8. All right, so to do the 21 base 5 times 14 base 5, we need to multiply, we need to change it to base 10. So in order to do that, we need to multiply the place value by the powers. So 1 plus 5 is 10 is equal to 11. And then we do 5, 4 plus 5 equals 9. So that would give us 9 times 11, it would be 99 base 10. So now we need to take that in base 10 and convert it back to base 5. So to do that, we would divide it by the powers. Sorry, that's 125. Just wanted to check my work. Okay, so we know that's too big. So we're going to start with our place of the 25. So we would take 25 divided by 99 would be 3 would be 75. 24. And then that would give us a 3 remainder 24. Then we would say we bring that 24 over, and we're going to divide that by the 5. So 5 divided by 24 be 4 be 20. Remainder 4. Sorry, I'm trying to do this too fast. So 4 remainder 4. So we're going to take that and bring it over to 4, and we're going to divide it by the 1. Gives us 4. Remainder 0, which is what we're looking for. So our answer is going to be 3, 4, 4 base 5. So 21 base 5 times 14 base 5 is equal to 344 base 5. All right, so number 14 says, does division have associative property? Give a reason and an example. No, it does not, because associative property is when changing the grouping of a problem, the answer will still be the same. This is not the case in division. So like if you say 6 divided by 3 is grouped together, and then you divide that by 2, that would give you 1. But if you divide 2 divided by 3 and then divided by 6, that's nowhere near 1. So it does not, changing the grouping does not keep the same value as it does like an addition or multiplication. So does subtraction have commutative property? Give reasons and example. It says no, because the order subtraction changes the result. So like say if you have 2 minus 3 is equal to like -1. So that does not equal 3 minus 2, which equals 1. So it changes the value of the answer. All right, so let's do number 15. It says 27 dogs are in a kennel. 13 of the dogs are gray, 7 of the dogs have short tails, and 17 of the dogs have long hair. There are 2 dogs that are gray with short tails and long hair. 2 of the dogs are gray with short tails and do not have long hair. 3 of the dogs have short tails and long hair but are not gray. If all the dogs in the kennel have at least one of the mentioned characteristics, how many dogs are gray with long hair but do not have short tails? All right, so we are wanting to find out how many dogs have gray with long hair and no short tails. You know what, let's change this. Let's do gray, long hair, short tail. All right, so what I did is I created a chart that has all of the dogs. Like there's 27 total dogs. So I made a chart of all of the 27 dogs so we can look at the characteristics each dog has. So we are looking for the columns that total our X. Our X is gray with long hair and no short tails. So we want the ones that both have, oops, fill this column up. So they're going to have both of these in common. So first we need to find out which each column represents. So we have they gave us that 2 dogs have gray with short tail and long hair. So that means they have all of them, all the characteristics. So they have 3 dogs. 1, 2, 3, or 2 dogs have all 3. Then we have 2 dogs that have gray with short tails and no long hair. So we have 2 that are gray that have short tails. Then we have 3 dogs that have short tails and long hair but are not gray. So that means we have 3 that share these 2 characteristics. So then we need to go back and look at our totals up here. We have, if you look at the short tails, they have a total of 7. So we have 1, 2, 3, 4, 5, 6, and 7. So all of our short tails are accounted for. So there's no dog that has just a short tail. So then with long hair, we have 1, 2, 3, 4, 5. So we have 5 and we need a total of 17. So let's see, we do 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So we have a total of 17 dogs with long hair now. And then we have 13 with gray. So far we have 1, 2, 3, and 4. And we need to add up to 13. So we're going to start down here. So 5, 6, 7. Oh, wait. We're going to start here. 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have only one dog that is both gray with long hair. So X is going to be equal to what? It's a little confusing. I did a Venn diagram up here to kind of show the same thing. So you have 11 dogs that have long hair, 8 that have gray, and then you have no dog has 0, or no dog has a short tail only. So we have 2 that share gray with short tails, 2 that share all of the characteristics, 3 that share the 2 characteristics, the short tail and the long hair. So this was the area that we were looking for the connection. So if you add it all up, you have, so the gray section needs at least 13. So we have 8 plus 2 is 10, plus 2 is 12, and then you have the 1 here is 13. So 17, you have 11 plus 3 is 14, 15, 16, 17, and the short tails, they have 7. That's kind of how I did 2 little methods there to figure it out. Let me know if you have any other ideas or ways to do it. All right, let's see. All right, so on B is show the strategies that you use to solve this problem. Which 2 mathematical content and 2 mathematical practice standards did you use? So if you look at South Carolina College and Career Ready Mathematical Process Standards, our standards are, there are 7 of them. 1 is to make sense of problems and persevere in solving them. 2 is to reason both contextually and abstractly. 3 is use critical thinking skills to justify mathematical reasoning and critique the reasoning of others. 4 is connect mathematical ideas and real world situations through modeling. 5 is use a variety of mathematical tools effectively and strategically. 6 is communicate mathematically and approach mathematical situations with precision. And 7 is identify and utilize structures and patterns. So those are your standards. I used make sense of problems and persevere in solving them, and then reason both contextually and abstractly. And then the content standards are things like you have number sense, algebraic thinking and operations, geometry, measurement, and data analysis. So I used algebraic thinking and number sense.